Hey students, I want to talk to you today about antiderivatives. So we're just getting into our last standard, standard 7. We have a lot to do with evaluating integrals, and antiderivatives play a huge part in that. So we need to talk about that. We already know what a derivative is. Hopefully, just by me saying the word antiderivative, you know what the prefix anti means, kind of the inverse of, doing the opposite of, going backwards, if you will. So let's say we have this expression right here, x to the fifth plus 2x. If we're going to do the antiderivative of that, it's simply what's it going to be so that when we take the derivative of that, gives us this. So we know we're going to have to go 1 power higher than 5, right? Because we know with the power rule for derivatives, when we take the derivative of x to the sixth, part of the process is this decreases by 1 to take us to x to the fifth. But if we just left it with this, if we took the derivative here, it would be 6x to the fifth, right? But we don't want a 6 there, okay? So how do we get rid of that? Well, if we put a 1/6 in front of that, 1/6 times x to the sixth, if we were to do the derivative, we bring the 6 down, multiply that by the coefficient. So 6 times 1/6 is 1, x to the fifth, right? So this is the antiderivative of the first term of 2x. That one's going to be x squared. And when we do the derivative, the 2 comes down, and then it works out. So one other quick thought. When we do the antiderivative, normally we talk about having a plus c, plus some constant, right? Because imagine, if this was, I don't know, plus 7, okay? That would be the end. If we took the derivative of this, we would get that, right? This could be any number. It could be -5, right? And it would still give us the same derivative. So we kind of get this family of functions where we just put a plus c, that this could be any constant here. And so think about the graph of what's going on. If we were to graph this, it'd be some funky curve. But what's this plus c going to do to it? Well, it's just going to shift it up and down, right? And so you're going to have, I'm going to totally butcher this graph, but my marker's going bad too, sorry. But let's say this function looked like that. I don't know, something like that, okay? Actually, it's probably going to be going up on both sides, okay? So something like that, okay? That plus c is just going to, it could be any one of these, and they're still all going to have this for the derivative, okay? So your antiderivative is going to be a family of functions that can be shifted up or down depending on that c, all right? We'll get into that more later. But now, for now, know what it means to find the antiderivative. Here's another example. Again, I just kind of have a polynomial function here. These ones are usually the easiest to find the antiderivative of. So in this case, I know it's got to be x to the fifth, but what am I going to have to put in front of it so that I get a 6 in front when I take the derivative? Well, I'm going to have to put a 6 over 5, because when I multiply the 5 for doing the derivative, I'm thinking backwards on this now. When I put the 5 out here, that 5 would cancel with this 5, leaving me with 6, and then that would go down to a 4. Okay? Plus x to the fourth, and I'm going to need a 1/4 in front, so that 4 times 1/4 gives a 1. This one I need an x squared, so I have to have a 3 over 2 for a coefficient. And the -5, I'm going to have minus 5x, and then a plus c. There's your antiderivative. Okay. One more to show you here with some trigonometry functions. I'll let you take a look at that a second. So we kind of take each term separately, okay? So what's going to give us a derivative of -9 sine x plus 6? Well, it's going to be, if I start with cosine and I take the derivative of cosine, I get negative sine. So that's going to give me my negative, so I'll just put the 9 out in front, cosine x plus 6. Okay, and normally I would have to do the chain rule, which says then take the derivative of the inside. But in this case, the derivative of the inside is just 1, so that's okay. These get pretty complicated when you have to consider the chain rule, and I'll be teaching you a method called substitution to help with this next week. But now these will all be pretty straightforward. This one here, tangent has a derivative of secant squared. So I need -6 tangent x plus 3. Okay. And now this one here, we want to think of this as 9x minus 4 to the -1. But 1 higher than -1 would be 0. Okay. And so that's not going to work, though. We can't make it work here. And so this is a situation that we kind of skipped over. We didn't do a lot of. If you have something like x to the -1, or in other words, 1 over x, that is the derivative of natural log of x. If you take the derivative of natural log of x, you get 1 over x. Okay? So in this case, the derivative that's going to give us this is 9 natural log of x minus 4. Okay. So again, we didn't do a whole lot of that, but this is, I think it's helpful for you to see that once in a while. That is the natural, if you take the derivative of natural log, you get 1 over that value. So that works out here. There you have it. Okay. Now the last thing I want to point out is how this relates to integrals. Okay. When you, let me go back to this one. Okay. So I had given you this initially here. Okay. Sometimes you'll see it written as this, plus x cubed plus 3x minus 5 dx. Okay. And you'll see it like this, but you'll notice this is not a definite integral because there's no numbers here. Okay, so we're not looking for area under the curve with this. This is just the indefinite integral, which is just, for right now, you just need to understand that that's telling you to think about the antiderivative. So right up here, this is your simplified answer, or another way to rewrite this. Okay. So just for now, understand that what I just showed you with antiderivatives is how you evaluate indefinite integrals. They don't have numbers here, just that. All right. So good luck with your homework today. Let me know if you have any questions along the way. Have a great weekend.